Dr. Mohan is a technologist with experience in leading high-performing teams at startups, in academic research, and within the industry. He is highly skilled in engineering, technology management, pre-sales, and business development, including in mission-critical and large systems. And he possesses a PhD in computer science and engineering. He is currently senior industry principal at Infosys and an industry fellow at Deakin University. Before that, he was the Senior Vice President of Innovation and Research at Wells Fargo India Solutions. And before that, the Senior Domain Expert at the Institute for Development and Research in Banking Technology in Hyderabad. His research scholarship took place at IIT Hyderabad at the Software Engineering Research Center. And his educational background, his PhD was awarded by the International Institute of Information Technology. Previously, his alma maters being Jawaharlal Nehru Technological University and the University of Hyderabad, respectively. Sir, hugely excited for your lecture. And with that, I would like to give you the floor so that our students can gain expert insights into threat intelligence.
Thank you so much. And I know it's a Friday evening and probably one of the last sessions. I'm sure you're all excited for the weekend to come. And hopefully you have enjoyed the overall sessions. Um, the the lucky thing that I had in my experience was some of the work that I was doing at RBI Institute, IDRBT, around threat intelligence became part of my PhD problem at IIIT Hyderabad. And subsequently, while I tried to work for a couple of companies, the current company where I'm working at Infosys, I again got back to threat intelligence. So today's lecture, I thought I'll first talk generally about what is threat intelligence. Then I thought if I just talk generally about threat intelligence, you might find a lot of information that's already there in the internet, or probably, yeah, can relate to information that is on the internet. Rather, I felt let me talk about the threat intelligence that I try to do as part of my PhD, so that if you ever are keen about threat intelligence, you could use this as a reference to build it. And this, what I did, is also available on the GitHub. So you could also fork it, you could go branch it out, or you can copy the repository and do what you want. So don't see it as an extension of a lecture, but you can also explore the opportunity of taking something around this and try to build around threat intelligence. The first part, just to make everyone aware of threat intelligence, I'm, I'm sure we all understand the word intelligence. Hey, is it okay if I take out the video because I'm running on a low bandwidth on my mobile? So I'll take out the
Of
video.
course.
Yeah,
Of
thank you.
course, sir, no problem. I also turned off my camera, because you mentioned that the bandwidth might have issues, so it would probably make it more streamlined.
Correct. Thank you. Um, so first, I thought I mean, we all understand what is intelligence, right? And the word intelligence, the word knowledge becomes very paramount, especially for people who are trying to understand what this PhD is. Not to antagonize people who are thinking about PhD, but some people that I know very personally, they used to say PhD means permanently head damaged, right? But PhD means a doctorate in philosophy. It certainly brings a framework in terms of solving some unknown problems and adding to the knowledge. Right? It's all about adding to the knowledge, and intelligence is obviously about knowledge, and not just knowledge, but also the foreknowledge, which is it's beyond information that is available and trying to foresee what is available and then use that as an intelligence to handle a situation, right? In one case, it could be a PhD problem. In other case, could be a cyber incident. So what I'm trying to say is intelligence, threat intelligence would mean not just looking at or using the information in a more meaningful way, but also using some other indicators to foresee a possible attack that might happen or an incident that might happen, and then go look at what we can do within the organization. Now, I'll try to pull the presentation, but I just wanted to make sure that we understand the word uh, intelligence before I talk about what my work is. I'm not going to talk about giving Gyan on threat intelligence. I'm going to talk about what I have taken as an approach in terms of building a cyber threat intelligence platform. Um, now, um, threat intelligence becomes very relevant, especially if you look at dark web, where the activists, individuals, nations, organizations are trying to exchange information that they were able to get about an organization or about an individual and see what is that they can exploit. And that could be documents of Lady Gaga, it could be documents of a company, it could be a credit card information, it could be a business email ID that is getting compromised, right? And all this that they try to do is use this data to make a claim for a ransom, right? Now, if organizations don't understand that they also need to look at what is happening in the deep web, dark web, they think protecting organizations within a firewall or an academic institute, just putting a firewall, putting a active directory, or putting some rules in terms of how everyone should do, or thinking about putting a antivirus or a MDR is good enough. Absolutely not, right? A lot of information is also coming from outside, and they should look at what it means in terms of the tactics, techniques, and the procedures that the attackers might follow to create some adversarial situations. What I preluded to is a framework called MITRE that you might have heard. If not, yeah, please look at it. It'll give you in terms of how a typical thief, if you can recollect in a real world, if they want to do a burglary at your place, first they'll come understand, yeah, what is that the local environment is looking like, right? We call it as reconnaissance. Then they look at, yeah, based on this, what are the weapons that I would need? And then they go doing the subsequent activities. Now, that applies even in the cyber world. And the threat intelligence is to understand what those guys are thinking so that before an organization goes through an attack and takes a reactive approach, can we take a proactive approach, right? That's essentially the cyber threat intelligence. Now, what I will do is give you a walkthrough of the platform that we try to build, um, and and talk about what you can do in terms of if you want to really explore it, right? So let me give you some more context, right? If you all have used Google, why threat intelligence becomes very relevant, I'm trying to relate. If you all have used Google or Bing or any of the DuckDuckGo or any of the open generic search engines, and you try to search on a keyword like properties, it'll get, in some cases, HTTP properties. In a lot of cases, it can go get a real estate property. Now, what it is throwing out is a situation of not having that context, right? Not having in a cyber world the applicability. If I'm trying to search for Lalit and it gets some other Lalit, not the Lalit Sanagavarapu who's addressing now, the applicability is not there. And obviously, the information that the dark web search gives is not good enough to see if there is any proactive measure that I can do for containing the attack. I'm taking an example that is publicly available on a generic search engine, but the similar situations would exist when you try to go do a crawl, not understanding the applicability for the context in which you're trying to search. Now, what? Yeah, the problems of bias, content, filtering, click spam, deep, dark, public, everywhere the same problem exists. Now, if you try to contextualize, it becomes like what you're trying to do on a Yahoo Finance, right? Yahoo Finance is a search engine which is meant for financial domain, and you try to search about Wells Fargo, it only not talks about Wells Fargo in Hyderabad or Wells Fargo elsewhere. But since it's a finance generic search, finance specific search engine, it'll get you things related to the stock price. What are the adjustable rates? Because it's a finance engine and you're searching about Wells Fargo. Wells Fargo is a financial entity. It's trying to get you a little more context, which applies for the keyword that you are trying to search. Similarly, um, if you go do a Google Scholar, you would have a similar situation, right? Google Scholar is a knowledge repository for academic search. Now, what I'm trying to tell you is the key aspect of any threat intelligence is the applicability and the contextuality or the relevance. Otherwise, it is no good. And how do we do that? Is the approach that I'm trying to bring in, right? Um, Now, I try to do this threat intelligence using what is available on the public search, but not necessarily going and trying to do for the deep web, dark web yet. I could have extended it for the web crawlers for the deep dark web. So hopefully some of you will get interested about this topic and use my GitHub repo to extend it for the deep or the dark web. Um, Now, generically, if you look at any search engine, um, whether it is a Google, whether it is a Bing, whether it is a search in the Tor world, that's the dark web, it follows few aspects. One is you are obviously on the www on the internet. You would need to do some crawling, which is more focused to the context that you're trying to search. And your inputs could be a Twitter for the social media. It could be a probably any of the sites that are into the dark web, or any of the information that you feel where you would have content that is rich in the context that you would find relevant. From that, you get the seed URLs. Seed URLs, like the way that you have um, a seed for it sowing up. I mean, a seed that you sow to get a plant. Similarly, there are URLs which have which are enriched or which have a lot of URLs which could be of your interest. Now, the way that seed is coming out is if you put a seed, you get a plant and that gives you a lot more seeds. Similarly, you have a URL which has more URLs that are related to your topic, then that is actually a seed URL because that's really a real good quality URL or a seed URL which can lead to some more contextual URLs from which you can get the content. Now from that, you do a crawlers, you go get the extract page, build a knowledge base, and that knowledge base could be in the form of a semantic business rules and vocabulary. It could be in terms of um, an ontology, and I'll talk to you about what those are. It could be probably a rule engine, or it could be some framework in cybersecurity called OCSF, Open Source Cybersecurity Framework. And that you go put it into some form, go rank it based on the credibility of the information, the source of the information, and then provide a user query. So if you look at it from a threat intelligence perspective, let's say I want to know if Lalit name is being discussed in the dark web for whatever reason. Lalit could be Lalit Modi, Lalit could be the recent Supreme Court justice, the Lalit could be this Lalit, or there could be many more Lalits. Now the user puts a query, gives a keyword, and in the engine it goes does all this behind the scene, keeps a knowledge repository. So when the user is making a query, it goes to this index web which gets the contextual information based on the relatedness in a graph. I mean, the information is presented in a graph format. So the ones which are closer to this node, the darker node, to this node, let me see if I can use a pointer. Yeah, uh, yeah. This node is closer to this node as compared to this node, right? Now, what I mean to say is when it is trying to get the relevance, if the information is stored with the related ones closer, so when I see Lalit, it will go get me the credit card of Lalit if it is available in the dark web, the email ID of Lalit if it is available in the dark web, the password of Lalit if it is available in the dark web, or probably some other personally identifiable information of Lalit in the dark web. Now, because we have stored in a graphical format, I mean, there could be some information here too, not so much related to the Lalit, but could be Lalit's family's date of birth, right? So this gives you the opportunity of getting all the things that are relevant to Lalit and accordingly show it. And that information that is shown is fed into threat, I mean, threat platform, and that goes into any of these cybersecurity, uh, security information and event management tools to see if there is anything that organization needs to do from protecting the assets. It could be protecting the asset of an individual, protecting the asset like a server, protecting the asset like some database which has some sensitive information, right? Um, Now, first, in terms of how do we get the uh, seed URLs, how do we keep them enriched? We could have done in any way, right? I could have just kept crawling the dark web using. I mean, we try to use an algorithm, reinforcement uh, learning algorithm. I could have used the normal crawler like a beautiful soup to keep getting information for a given set of keywords from the internet. Now, what we try to do unique is um, some of you would have heard about nature-based algorithms. So we look at in the nature the way that ants walk around to find food, and then the subsequent ants go and get follow the same path and accumulate the food. Or if you look at how fish or shark goes for a hunt, and in fact, the shark algorithm is one of the most famous that was used in terms of developing a search engine. If you go read in terms of what Sergey Brin, the founders of Google did, Larry Page did, is actually extend that nature-based algorithm in terms of how shark fish goes for a hunt. Now, one of those ideas that I had in terms of finding the seed URLs and extending in terms of building my repository through which I can do a crawler is something called ABC. ABC is artificial bee colony algorithm. Let me tell you what that artificial bee colony is. Now you look at any beehives, um, the queen bee comes, sets up with the worker bees, the beehive. Right now, how does that beehive gets filled with honey? Um, the story goes like this. So the worker bees goes into the wilderness, finds one of them goes finds a flower patch and comes back to the beehive, and you know what the worker bee does? It actually goes gives, I mean, does a dance in two ways. One, it dances in a vigorous way, which means there are so many flowers in that patch. The more it vigorously dances, means that there are no more number of flowers. Second, when it dances in a particular direction, which tells the subsequent bees to go into that direction to go fetch for the honey to fill um, the beehive. Now there are worker bees, there are onlooker bees. The onlooker bees finds goes and finds out what is the next flower patch that they have to find out. That applies even in the world of internet. If you actually want to go get content or you want to get URLs fast and then go get the content. Now we use the same algorithm, we extended it. In our case, we can't apply bees in the computer. So we talk it as the agents. So it is a multi-threaded programming that runs. And for us, the roots are those IP addresses to go get the required or the interested URLs through which we can source content related to topics of interest, right? Um, and there is some metrics that we put in terms of extending this algorithm to see whether it is efficient, how efficient it is, how much diverse it is able to get it. Because I don't want to get content only Lalit, Lalit, Lalit all the time, right? I also want to get uh, content that is related to Lalit, content that is also related to Lalit's family, a family's family, and I would first want to get the information of credit card, then not just always the credit card, but I also want to see if the information related to Lalit's address is available in the internet. So the diversity is important as much as the content quality, right? That's the relevance I'm talking about. So we've put some metrics. We actually compared this efficiency of this algorithm with what exists as public crawlers, right from Nutch, Solar, Nutch, Beautiful Soups, from relevance, diversity. Obviously, we factored it. It is going to be good. Even from CPU utilization, because we are using threads, um, and the amount of network that is going through the pipe, we are certainly very optimal in terms of how the algorithm is working. That's an exciting part because in a dark web, when you're trying to gather information, I don't want to get information of 10 years old, right? I can't wait for 1 year to get the information. I'm trying to get intelligence before the incident really happens. So I need to be really proactive. I need to be really optimized in terms of how fast I'm able to gather the information. That's the advantage of the algorithm that we try to put in, right? Now, first I got the information. Yeah, I'm talking about some of the comparisons that we did in terms of cybersecurity. Um, I mean, I'm not going to go deep in terms of explaining it, but all I'm trying to say is there is good an amount of diversity. There is good amount of URLs that are available. There is good amount of um, richness of the information that is there. So it kinds of works out that it's not an algorithm on the paper, but an algorithm that is implemented and working efficiently, right? Now the next part is I got the information. I need to store in some format so that when I want to search, I get the ones which is the most relevant, right? First aspect I did is getting in the noisy world information that is relevant. But I know that is not 100% always going to be relevant. Second part that I'm trying to do is in the relevant information that I got, I want to see how the ones which are more related are put together versus the ones less related. So if I have information about Lalit date of birth, Lalit credit card information, Lalit's address, Lalit's family address, Lalit's family's date of birth, the ones that are more related are obviously the Lalit's PIA. Then comes the next family's PIA and subsequently the rest of the family, right? Or an organization, because threat intelligence at the end is not just protecting the information of individual, you're also trying to protect the information of organization, right? Now that structuring is something that we call it as ontologies, right? What are ontologies? Ontologies are concepts um, of an object and a subject with a relationship that's called predicate, right? Now, in the I'm just going to the block diagram that we started. The first part that I discussed is this one, right? Which I talked about in terms of getting the information. The new part that I started just talking about ontology is, let's see if I can change the color, is this part, right? Where we are trying to use the information that we got through the crawlers, put it in a representation with ones which are more related close to each other. That way when I'm trying to search from here um, to this through these mechanisms, I get the ones which are most relevant. Right now, I could have taken. We are talking about information that is more in the text format. We're not talking about information that exists in an image. We are not talking about information that exists in a video file. We are not talking about information that exists in a speech. We are only talking about information that exists in a textual format. Um, if someone wants to, in the dark web, if there is a picture of an individual that should not be put, but that exists, very sensitive picture. Um, yeah, the dark web threat intelligence can do that. But in this in this specific implementation that we did, we are only dealing with the textual information that exists in the web, right? The way that we try to do is, so we started with some inputs. Um, we try to identify concepts, and there is something called DBpedia because we are dealing with the public web. One rich source of information for a variety is the Wikipedia, and the DBpedia is um, a representation. DBpedia is a representation of Wikipedia that you can query using a query language called Sparkle. Sparkle as in SP, right? SP, like if you are engineering students or if you are into technology, you would have come across something called SQL, which is um, simple query language. These are this is also similar. If you look at syntax, it will also be similar to SQL on the database. But yeah, this also um, is a query for a graph database kind of stuff. The Wikipedia information is stored on DBpedia, and that DBpedia uh, data that you can search using Sparkle queries. Now, what we did is we got that content. We want to build an ontology. So we hypothesized one initial ontology. So I would say for Lalit, um, has these attributes. He has age, height, weight, which are probably not so relevant, but um, salary details. Then not Lalit, but let's say at a conceptual level, which would mean a person, right? A person would have specific PIA. An organization would have specific areas of interest. Now, those uh, concepts, whether it is an organization like um, Infosys, an organization like probably HDFC Bank, an organization like Walmart, some of those things are common. Similarly, for a person, whether the person is in India or the person is in US, while the privacy laws are little different, so what people think is important is little different because of the nature of the culture there. But generally, if you look at it, I think we are all sensitive in terms of putting our mobile number on the internet. We're all sensitive of not sharing our salary. We're all sensitive of not sharing uh, any other personal details on the internet. So those attributes are the attributes of this ontology. So what we did is created an ontology in the area of information security, and we used DBpedia to keep enriching it, because today I might think for Lalit or for a person, these are the important things. And Lalit is an instance of a person, right? Lalit is an instance of a person. Now, Lalit as an instance of a person is called knowledge graph. If you go search how search happens on internet through Google, Bing or anything, they use something called knowledge graphs. These are instances like you would see in programming languages, classes, objects. You could say an ontology is like a class, a knowledge graph is like an object, right? It is those instances. Now, what we try to do with this approach is go keep enriching the ontologies, because we are trying to understand more attributes of an individual and then also relate to an instance. So I would try to see probably date of birth was not there at the beginning as an attribute. Now I identify date of birth as an attribute in the graph. And I would say Lalit, date of birth is so and so, and Lalit is a representation of a person, right? So I'm from the information that we collected, we are enriching an ontology. We're also enriching the knowledge graphs. So like the way that you would have in a database, you're trying to query information, and when you're trying to query information, you would want records of interest to be available. Similarly, Lalit record is of interest. Lalit, these attributes are of interest. That becomes easy in terms of the query process and obviously the relevance or the applicability for a threat intelligence provider, right? Um, this is an example that we did. How did we do it, right? We used, since I said we started with text, we obviously used some natural language processing algorithms. We also used a bidirectional LSTM uh, so that I get the information, the importance of bidirectional LSTM. First, the importance of LSTM, which is long short term memory, a deep learning algorithm, which looks at not a piece of a word in terms of building intelligence or memory for understanding what the next word should be, but it also has some amount of memory, right? And a bidirectional LSTM, if there is a sentence, it goes forward, it also goes backward to understand which word is related to the other word and accordingly stores in its memory so that when there is a new word, it knows, yeah, this is how I need to relate them, or this is the next word that is possible. So bidirectional LSTM is used in terms of building knowledge graphs. Bidirectional LSTM is used quite a bit in terms of machine translation, um, that or speech processing. So when someone is saying it, if there is an algorithm that has been trained and that algorithm is a bidirectional LSTM, so after I say something, it knows what is a possibility of the next word being so and so, right? Um, this is actually something very interesting, right? And deep learning algorithms required a lot of data. We had about the crawler extracted about 1 TB of data, and just this piece we had some GBs of data to train the model and accordingly do the prediction of what the next related word would be for enriching that ontology, right? So I'm again, yeah, this is some efficacy values which says the algorithm worked well in terms of F1 score, precision, recall. If any of you are in the area of machine learning, you would very closely relate. And typically, machine learning doesn't mean that it is always 100%. It is a continuous process, and 80% plus accuracy would mean, yeah, it is a decent job. It is doing a decent effort in terms of identifying and enriching the ontology. So we are close to that 80% in this case. Um, Now I build that ontology. I obviously want to validate whether the ontology that I built is sufficient enough. Um, Otherwise, yeah, I keep adding some attributes. Let's say that I add an attribute for person chair, right? Person chair, if there is a predicate which says sitting, so person sitting on a chair makes sense. But person chair and it says height, right? There is no relationship. So we also looked at how do we evaluate, and we used actually one simple one, which is the lightweight approach. We also used some crowdsourcing approach. We also put some algorithms in terms of evaluating whether that enriched ontology is actually good enough or not, because otherwise you keep building ontologies and if they are not sufficient enough, you're only creating more noise, which would not help in threat intelligence, right? I mean, this is some evaluation. I'll share the slides, or probably there is a recording. You would anyway have access to it. And there is a GitHub repo for you to validate, understand, extend it based on your interest. Second is the third part. So I'm just going back in the diagram. Um, Here we did first activity we did was extracting information. Second activity we did was in terms of enriching in ontology. The third activity that we should be doing um, is this, which is I need to know which is the most important one to begin with, right? How do I know the information that I got is credible information or not? Because I'm also playing in the deep web, dark web, surface web. Um, so if I say, yeah, um, Lalit is a bad boy, or Lalit's date of birth, so we did some experimentation. We checked out uh, what is the date of birth of Sachin Tendulkar. It said Ferrari, right? Um, S- Sachin has a beautiful Ferrari car, but Sachin date of birth is not Ferrari. Then we improved something. It said Sachin's date of birth is um, 1976, some date, but that versus another one that said Sachin's date of birth is 1970. Now, which one is the right one, right? Which is the more credible information? How do you know? First one is we asked date of birth, it said Ferrari. Second, it gave some date. Third case, it gave another date. Which one among these three is credible? Because I need to, when I'm trying to provide threat intelligence, I obviously need to be as accurate as possible. Otherwise, the organizations or the individuals look at threat intelligence and say, yeah, this doesn't apply. So waste of information, a waste of human effort in terms of trying to deal with it and do something within the organization which has no applicability. Right now, that essentially talks about the importance of credibility. Now, we could have done credibility many ways, right? If you look at uh, Google's page rank algorithm is around credibility to certain extent, and not credibility, but it is more on popularity. It is more in terms of um, usage metrics, which is also tying up into the popularity. Uh, Popularity doesn't mean credible, right? Credibility can increase popularity, but popularity alone doesn't mean credibility. And when you're trying to deal in threat intelligence, cyber threat intelligence, you need credible information, not popular information. Some of you would have read newspapers, right? When you see read an article on a newspaper, this newspaper doesn't sound to be too credible. Versus a similar related article on another newspaper, you get that sense, yeah, probably this information is more credible, right? Now, which obviously means the importance of credibility is very relevant, especially in the threat intelligence services. Um, so what we looked at, right, from surface features, when I say on the web, we are trying to assess the credibility, right? Surface features, it could be um, the English, um, no, not the English first, the layout of those pages. If there are too much images or there is content that is, yeah, is too flashy. If there are spelling mistakes there, off-page features, which could be how the URL is structured. Where is that URL being referred to, right? If my URL is linked to many pages and that many pages are credible in nature, it is a cyclic process, which means probably there is some credibility to that site, right? Or if it is just a standalone, then there is some masquerading page that is put and only trying to throw some um, gray articles or dark articles which are not credible in nature. And that's probably the fake news, right? Um, now, we looked at surface content off page. We put some APIs, publicly available APIs, some proprietary APIs that gives us some satisfaction in terms of the information that is available in that content. We applied some normalization rules to see which of them do apply, do not apply, and obviously did some correlation, right? Now, what we did interestingly beyond this is an aspect called genre, right? If you look at, you would hear in the storybooks, there are genres for fantasy, there are genres for science fiction, there are genres for probably uh, biography kind of articles, right? there are different genres when you're reading content. Um, Research articles is one genre, right? They those kind of articles have a similar kind of a tone. Um, they use probably similar kind of language. Some of them put information in a very flashy way. Some of them put it as statistics and figures. Some of them, yeah, use probably what do you say? Um, More of an image versus a content. But at the end, there is some genre that exists on the internet too. If you look at content specific to security, um, Times of India could be saying that an XYZ bank went through an attack, or Times of India could be saying that this software product from this company has this breach, versus certain from Government of India could also be sharing that information. And you understand the genre that newspaper articles bring versus the government websites, not the domain, the government websites bring is different, right? Obviously, the credibility is different. So we looked at content to identify those genres and accordingly add that relevance figure to the ontology that we are enriching to make sure when the threat intelligence needs to be identified, we know we are getting from we are getting from sources which have a lot of information. We are putting in a structured way so that the ones which are relevant are coming first. Third, we also know that it is not relevant, but it is also credible in nature. Right now, this effort that we try to do, I mean, we try to compare with Alexa. I mean, not the Alexa on the Amazon, but yeah, Alexa, this company is also probably one of those companies. But Alexa has the top million websites in the organization in the world, which are ranked 1 to million, right? There is something called Web of Trust. Web of Trust is a crowdsourcing approach of you would have it as a plugin in the browser. It'll tell you, yeah, this site is more credible versus other site. So, and fact is our approach, which is this approach. Um, the credibility assessment approach. We see that we are, I mean, we did a comparison of Alexa versus Web of Trust. They're not very relevant because Alexa would go through more of a popularity. Um, and we did Alexa versus Fact. Again, ours is not popularity based. So like Web of Trust, our fact score are also not so much correlated. But if you look at Web of Trust, which is again crowdsourced, so individuals trying to say which site is more credible versus others, we are more correlated in our approach to the crowdsourced or the Web of Trust way, which means that this approach that we are talking in terms of credibility assessment is how people see credibility as a piece of information, right? It is closer to the human reality. So yeah, it only says the approach that we have taken is fair enough and aligns to the way people think and would like to assimilate information from a credible source. Right now, we used this in the context of cybersecurity, that approach. Now, specific to the threat feeds, you have threat feeds like certain, you have threat feeds coming from open source threat intelligence providers like Alien Vault, OpenCTI is quite a bit, DeepSight is from Symantec, X-Force from IBM, Shodan is on the more on the network side. But yeah, some of them are public, some of them are open. And yeah, not everything is in the form that you can actually consume, because while IBM X-Force or DeepSight would be in the form that you can consume, but they're all paid sources. Those open source threat intelligence, now things have changed. Things are getting better. In fact, I mean, I'm talking about PhD that I did uh, 5 years back, or probably the last 2 years is when I got my degree. But yeah, the effort started 5 years back, or 6, 7 years back. That representation of in a way that you can consume did not really exist, other than some simple textual pages on the internet. Now, because of that, this approach becomes very relevant because you want to use it for security. You want to actually apply it. Um, and yeah, we build this platform so that people can go consume it and use it for taking those advisories and containing those threats before they actually happen, right? Threat intelligence is acting or preventing before the attack actually happens. We did some survey to validate whether it is making sense, and yeah, it actually got some excitement. We presented in DSCI, Data Security Council of India. The chapter that is one of its chapter is which is organizing this session, very well recognized by the Center of Excellence as well as security summits. And yeah, if any of you are excited to do it, do more on this, there is opportunity to do deep dark web crawling. I mean, I have methodology, we have to implement it. Um, no, I'm working, so I don't have development teams right now to work on it. But yeah, if any of you are interested, I'm ready to collaborate, support, and interact with you in terms of giving that inputs. Um, we also see that this can also be used not just for advisories, but also to understand potential vulnerabilities, attacks, controls, etc., etc. Right? That's pretty much some publications. We have a patent on this. We have few conference publications. We have few uh, journal publications because of this work or related to this work. Um, yeah, in fact, on the DBpedia, we have an article. DBpedia got excited about the work that we used at DBpedia, and they actually published an article on the DBpedia as well. Right? This is where I have my GitHub. If any of you are keen, please go use it. More than happy to guide. And that's my contact.
Thank you so much for your expert insights, sir.
Adam, can I take a minute?
Yes, of course, by all means.
Right now, I said what I did as part of my work at the Reserve Bank of India Institute became relevant for my PhD problem. And after a stint, I tried to do something at uh, an enterprise, large enterprise. Then I moved into Infosys. In the Infosys, I actually take care of something called CyberNext. And if you see here, the cyber intel is one of the areas that my product, I mean, the cyber intel here is an offering. So if any of you are interested, otherwise also we have a product which is actually being used by customers, not exactly the work that I did, but yeah, a product that we have and a platform that we service to the customers around cyber threat intelligence, right? So it's need versus research to a product platform that's available for the market. Thank you. Open for questions, Adam.
Thank you, sir. Thank you. Apologies for interrupting you a moment ago. I was under the impression that was your final slide. Your tone was so final. But thank you for your expert insights. Really, really appreciate you being so generous with your time and contributing to this year's cyber school. We have a number of students thanking you. Naveen, for example, is expressing his gratitude for your insights. I received a question in email from Aryan. This isn't the first time that he couldn't access the chat, but he would like to know more about nature-based algorithms.
Sure. He should look at meta heuristics. If he searches on the internet, meta heuristics or swarm optimization or nature-based algorithms, he'll find enough articles. But my email ID is also available here. So if there is any specific question, understanding an algorithm or implementing it, I'll be more than happy to share whatever I learned.
Thank you, sir. We also got an interjection from Samir. Can there be different hierarchy inherent in WOT and thereby having its own issues unless it's being audited?
Can you repeat that?
Samir's question is, can there be different hierarchy inherent in WOT and then he elaborates, thereby having its own issues unless it's being audited.
Yeah, I mean, we have to use something more reasonably related to validate. Web of Trust, which is the WOT, um, is crowdsourced, right? It goes based on the confidence score of an individual of a website. There is a metric that comes out. Um, so yeah, I think it is good to the extent that we believe in it, uh, but always questionable because you don't know how individuals, if they are playing with the system and just go give a credibility to the site, we don't know. But at the end, it's a crowd, right? It's a crowd, which means my sample is not 10 people, 20 people. My sample is the population that is using Web of Trust. To that extent, I still would go with Web of Trust gives a credibility to a site.
Right, millions of people.
Yeah.
Thank you so much, sir. Are there any further questions from the students? Dr. Mohan was also generous enough to open his email address to further inquiries. So if upon rewatching the lecture, the recording, anything occurs to you, please reach out to Dr. Mohan on the address displayed on the slide currently on the screen. And if there are no further questions for the moment, I would like to thank you once again, Dr. Mohan, for your expert lecture. Personally, I found it rather illuminating, and we really hope to see you and host your lecture next year as part of the Cyber School.
Thank you so much for giving the opportunity. And I'm always open for any collaboration. Um, yeah, if any of you want to reach out, I'm already sharing it. Otherwise, wish you all the best. And yeah, this is always learning. So if there is any feedback, happy to take that feedback. Um, yeah, otherwise, wish you all the best and have a very great weekend.
Thank you so much, sir. Wish you the same.